Hello students, welcome back to the another session of our data structure journey. In this session, we are going to learn how to construct a binary tree that is a balanced binary tree, that is AVL tree with the given data. You may get a question in your exam that construct the AVL tree with the following data. Means the data is given, list of elements is given. You have to construct the AVL tree or height balance tree or self-balanced tree. So any type of tree means the same thing. What is AVL tree? Basic concept of AVL tree I have already covered in my last video. In description section, I will put the link so you can just refer it so that it will be easy for you. Construction means one by one we have to insert the value first 10, then 30, then all the elements we have to insert. So insertion operation, how to perform, I have already covered in last operation. Just I will explain it. So whenever we go for insertion, what happened? We have to insert the element as per the binary search tree. After the insertion, we have to check each and every node balancing factor. The balancing factor should be in between it should be in -1, 0 or +1. Then only we say that the tree is the balanced. Otherwise, it is a imbalance. If it is a imbalance, then we have to make it to balance by suitable rotation. It may be RR rotation, LR rotation, LL rotation. So there are four categories. So all the details I have already explained them in my previous video. So you just refer it so that it will be easier. So let's start. So first element here is the 10. So we have to insert the 10. As there is no element, we have to create a node. So right now this node is root node. After creation, we have to calculate the balance factor. Balancing factor is the height of left subtree minus height of right subtree. So right now what happened? There is no subtree, so it is 0. Next element, so here what happened? Tree is balanced. If the tree is balanced, then we don't have to perform any operation. So next one is the 30 elements. So now 30 we have to insert. So whenever we insert, it will be as per the binary search. But what is binary search? All the element, the left hand side should be less than the root, right hand side is the greater than equal to the root. So 30 means what happened? Previously 10 is present. Now we have to insert 30. 30 is greater than the 10. So it will come to the right side. So node is inserted. Once the node is inserted, after that we have to calculate the balancing value. 30 node, it is a leaf node. It is a leaf node. So 30, we have to calculate the balancing factor for 30. As it is a leaf node, it's the balancing factor is 0. Now we have to calculate 10. 10 is left subtree 0, right subtree is 1. 0 minus 1, so it is -1. Next element, after that we have to check tree is balanced or not. Tree is balanced because it is in range between the 0, 1 and -1. Next element we have to insert. We are already insert the 10 and 30. Right now we have to insert the 15. So this one we are already done. Right now we have to insert the 15. 15 means we have to start from the root. It is greater than 10. So it will come to this node. It is less than 30. Less than 15 is less than 30. So it will come to the left hand side. Now connection established. After the connection is done, tree is created. We have to calculate the balancing factor. So balancing factor for 15 is 0 because it is a root node. Then 30 left is 1. Right is 0. 1 minus 0 is 1. Again, for 10, left subtree is 0, right subtree is 2. So 0 minus 2, it is -2. Now what happened? Tree is imbalance. Now tree is our imbalance. So now next question, we have to perform some rotation so we can able to achieve the goal. So here we have to perform RL rotation. Why RL? Because this is the right and left. Due to of right and left, we have to perform the RL rotation. So whenever we have to go for RL rotation, first RR rotation we have to do. So, so this node move to the 30 move to this one, 15 move to this one. So this way, after rotation of this two node, we got the, so it will 15 go to this place, 30 go to this place. So 10, 15, 30. So this is the intermediate tree. So here also you calculate the balancing factor. It is 0. Leaf node here 0. Left subtree is 0. Minus is 1. Right subtree is 1. 0 minus 1 minus 1. It is minus 2 because this left subtree is, height of left subtree is 0. Height of right subtree is minus 2. So 0 minus 2, 2. So again it is so what happened? Again we have to, as it is RL, so we have to LL rotation we have to perform. Means this one move to this one, then this move to this one. After this left rotation, what we got? This is the 15 go to this place, 10 go to this place. So 15, 10. Now after that we have to calculate the height or height of left subtree, height of minus height of right subtree. So it is 0. Balancing factor of each and every node is 0. So it is a balanced tree. So we got the AVL tree of only 3 elements. So 10, 30, 15. Next element we have to insert, that is 25. So this 3 element is over. So from the last balance factor, we are already got this result from the previous insertion. Now we have to insert the 25. 25. So it will start from root. It is greater than 15. So it will go to the right hand side. 30. So 25 is less than 30 means it will come to this position. So 25. Tree is constant. Node is inserted. After that, what happened? We have to calculate the balancing factor. Balancing factor of 25 is 0 because it is a leaf node. Then this one also leaf node 0. Then here height of left subtree minus height of right subtree. Left subtree is 1, right subtree is 0. So 1 minus 0 equal to 1. Then we have to calculate 15. So for 15, height of left subtree is 1. Height of right subtree is 2. So 1 minus 2, this is the minus 1. So minus 1, 0, 1, 0. So all the node have the balancing factor minus 1 or 0 or 1. So we can, so we concluded that this is a balanced tree. So next element we have to insert this 5. This is the tree we are already got from the last. So now we have to insert 5 means it will be inserted into this position. So insertion is done because it will start from 15. 15 is less than. So it will come to the 10. 10 is from here also. Next element we have to insert, that is 5. So this is the data we already got from the previous. So 15, 15, 10. So if we have to start from 5 in root node, so 5 is less than, so it will come to the left subtree. 5 is less than 10, so it will go to the left side. So it will create on the left side. After the creation, what we have to do? We have to calculate the balancing factor. So it is leaf node 25, 0, 5 also 0, both are leaf node. Then 30 means height of left subtree is 1 minus 0. So it is 1. For 15, 2 minus 2 is 0. Height of left subtree, height of right subtree, both are same. So that's why it is 0. So this is the height of left subtree is 1, height of right subtree is 0. So 1 minus 0 equal to 1. Now what happened? All the node have the balancing factor 1 or 0 or minus 1. So it is a balanced tree. So next element we have to insert, that is the 55. This is the tree we are already got from the previous insertion. Now we have to insert the 55. 55. So it will start from the, as we know, by insertion in AVL tree is initially like the binary search tree. So 15, 55 is greater than, so it will come to the right subtree. 30, it is greater than the 30, so it will come to the right hand side. So it is inserted. After insertion, ch- difference from the every binary search tree, that it has to calculate the balancing factor. Now we have to calculate leaf node 0. This is also leaf node 0. This is also leaf node is 0. Then what happened? So for 30, it is height of left subtree minus height of right subtree. 1 minus 1, this is 0. Then for next node, we have to calculate. This is the for 10, it is 1 height of left subtree minus height of right side, 1 minus 0. This is the 1. So now for this one, it is 2 minus 2. Here, height of right left subtree is 2, height of right subtree is 2. So 2 minus 2, it is 0. So now we concluded that tree is balanced because all the balancing factor is minus 1 or 0 or plus 1. So next insertion is 70. So this is the tree we got from the previous insertion. Now 70. 15. 70 is greater than the 50, 15. So it will go to the right side. 30. 30 also less than 70 means 70 will go to the right hand side. 75. 55 here. So 70 means 70 is greater than the 55. So it will go to the right side. So right side it is inserted. After insertion, what we have to do? We have to calculate the balancing factor. Balancing factor for 70 is 0. This is 1 minus 0 minus 1, height of left subtree, right subtree minus 1. Then this is 1 minus 2. This is the minus 1. Then this is 1 because height of left subtree is 1, right? There is no 1 minus 0 equal to 1. Then here it is height of left subtree is 2, height of right subtree is 3, minus 1. So this is also leaf node, so it is a 2. This one also leaf node, so it is a 0. So it is a balanced because all the node have the balancing factor minus 1 or 0 or plus 1. So it is a balanced tree. So now we have to insert the last element, that the 20. So this is the output we are got from the last insertion. Right now you have to insert the 20. 20 means 50. It will come to this position. After that 20 is greater than 15, so it will come to the right subtree. After that 30, so it will go to the left subtree because 20 is less than 30. Again 25, so 20 is less than 25, so it will become the right subtree. After that, we have to calculate the balancing factor. So here all leaf node have the 0 balance factor. Then we have to calculate this one. This is the left subtree is 0, minus 1, minus 1. Height of left subtree, height of minus height of right subtree, 0 minus 1, 1. For 10, here it is a 1, minus 0, this is 1. For 15, 2, the left subtree, right subtree is height of right subtree is 3, 2 minus 3. So it is minus 1. Then for 30, it is 2. Height of left subtree is 2, height of right subtree is 2. So it is 0. So now what we observe each and every node has the balancing factor either minus 1 or 0 or 1. So it is a balanced tree. So we concluded it is a balanced tree. So this is the way you have to construct the AVL tree. So whenever in exam it is given that construct a AVL tree or height balance tree or self balance tree, then what you have to do? You have to start insertion like the binary search tree. After the insertion is over, you have to check each and every node of the balancing factor. If the balancing factor is minus 1, 0 or 1, then it is a AVL tree. You don't have to do any rotation. If it is imbalanced means other than this three value, then what happen? You have to make any rotation. Right? Depend upon the in which sequence the insertion is done, so that the tree become balanced tree to imbalance. So this is the sequence you have to first find out. Then only you can able to find out which type of insert rotation you have to use. So that's why you have to, whenever after insertion of one node, tree becomes the unbalanced, you have to check it. Then only you can able to use. So balancing factor, height of left subtree and height of right subtree. So hope you are able to understand the example, solved example. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you so